Welcome to our YouTube channel. In this video, we are going to calculate wind load based upon ASCE 7 2010. In the left hand side, you can see an Excel sheet which is developed to calculate wind load calculation based upon ASCE 710. In the right hand side, you can see a PDF file which is the code of ASCE 710 which we required to calculate wind load. First input required is a basic wind speed V. This is as per class 26.5.1 of AAC 710. So for that we need to refer page number 289. So here is a definition for basic wind speed is provided. For that risky category 2 building we need to refer 26.5.1A. For risky category 3 and 4 we need to refer figure 26.51B. Similarly, for risk category 1 building, we need to refer 26.51C. So likewise, there are three numbers of figures to be referred to find out this basic wind speed. So for that page number 291, we need to check it. So here you can see that the US map for basic wind speeds for category 2. So depends upon the project location, we need to find out from this map. Similar like for risk category or occupancy category for three and four, we need to refer this map. So for category 1, we need to refer this. So we can consider here 120 mile per hour for our calculation purpose. Next one is we need to find wind directional factor. So that wind directional factor as per class 26.6 to be referred from page number 297. So here you can see the table. So this table is brought to here. So 26.61 table to be referred to calculate the directional factor based upon the structure type. So we are considering the structure type as a truss towards triangle, square or rectangle. So for that the KD factor is 0.25. So you can see this PDF file in the right hand side. So the value for trussed towers, triangle, square, rectangle is 0.85. Similarly, if you want to go for arched roofs, for that also the factor is same 0.85. Chimney tanks and similar structured square, it is 0.9. So likewise we need to pick based upon our structure category. So now the directional factor KD is 0.85 for our trussed towers, triangle, square or rectangle. Next one is exposure category we need to find out. For that class 26.7.3 to be referred, page number 298. So here you can see the exposure categories definition. Exposure B for buildings with a mean roof height of less than or equal to 30 feet or 9.1 meter. So this definition is clearly given here in this three: surface roof roughness, If surface roughness B means it is urban and suburban areas, wooded areas, or other terrain with numerous closely spaced obstructions having the size of a single family dwelling or larger. So likewise, three definitions are given for three exposure category. So for B, you can see here the definition which is extracted from the table here. So for D, it is flat, unobstructed areas and water surface outside hurricane prone regions. So this category includes smooth mud flats, salt flats, and unbroken ice. So we can consider the exposure C. Then the next one is the effect of a cliff or escarpment or equivalent height above ground. So this input we required to calculate the topography factor. So to calculate this topography factor, first we need to get the input what kind of topography is this our engineering project is going to be considered. So there are three categories of topography: 2D escarpment, 2D ridge, and 3D axisymmetric. So we can consider 2D escarpment. You can see here the picture showing the escarpment and ridge 2D or 3D hills. So in the right hand side also you can see the PDF file showing that picture about the escarpment and ridge, 2D ridge and 3D axisymmetrical hill. So the same picture is here in the left hand side also. So then the next we need the input like slope of the hill. If it is a plain terrain, there is no issue. We can consider the topography factor KZT as 1, or we have to calculate that KZT using the formula given in figure 26.81. That is page number 300. You can find it here. You can see here in the right hand side PDF file. Kz is equal to 1 plus K1 plus K2 plus, sorry, Kz is equal to K1 into K2 into K3 whole square. So slope of the hill we can assume as a 3, 1 is to 3. Height of the hill from above ground, that is h in the picture, is 150 meter. Distance upward, upwind or downwind from the crest to the building site x you can consider as 100 meter. Distance upward of crest, ground elevation is half of the height. So from the half of the height, that is at h2 level, to the crest in the picture it is mentioned as LH. So the same LH to be calculated based upon the slope and the height of the hill. So our slope is 1 in 3 and our height is 150. So multiplying the 3, I am getting 450, as LH to be considered as a half of the height. So I am dividing it by 2. So we are getting 225 as LH. Next one is height exposed to wind. We are considering as structure height up to 20 feet. We can consider whatever we want. So which is start from 15 meter to 400 meter. Generally this height is defined as per figure 26.3.1. So there are various height is provided under this class. So for various height defined as per figure 26.31, we need to refer page number 305. Sorry, it is 308. So here you can see the various height defined as per table 26.31. So we can consider height of 20 feet. So that could be 6.1 meter. So our Z value is 6.1 meter. So next one is we need to find out the K1, K2, K3 multiplier. For that we need to go page number 300. So here the formula is given to find out the K1, K2, K3. K1 is to be determined from table below based upon the exposure category B, C, D. So here in the right hand side tab of this Excel sheet, you can see that the same was calculated in backside to support the load calculation sheet. So this is a table which is extracted from the PDF ASCE 07-2010. So based upon the three type of topographic surface and based upon the exposure category B, C and D, the factors are extracted from this PDF 1.3, 0.75, 0.95 and those similar like for exposure C and D, and the gamma value and the mu value are extracted from this PDF file. And here based upon the H divided by LH. So we are having the H and LH. The K1 factor is arrived for exposure category B, C and D by applying this formula in the PDF file. K1 divided by H divided by LH. We already know that H divided by LH is 0.67 and the value 1.3 which is given here divided by this H divided by LH, we are getting 1.94. So likewise this exposure category B, C and D for all the three topography profile are calculated. Then for exposure category C alone, which we get selected here, we are getting K1 multiplier factor as 1.27. So through the interpolation and VLOOKUP method, this K1 factor is calculated. Now for K2 multiplier, the formula given here in the right hand side PDF is 1 minus x divided by mu LH. So applying the same formula, we are getting 0.56. Similar like a K3 multiplier also, there is a formula given in the ASCE 07-2010, which is K3 equal to e power minus gamma z divided by LH. So applying the formula, we are getting 1 as our K3 multiplier. So this calculation page, load calculation, we had calculated this kz factor by multiplying K1, K2, K3 and adding that into 1 and whole square. We are having the kz factor as 2.93. So likewise we need to calculate the topography factor. So this is the procedure. But for category C, if we are having only category C, we can directly take this K1, K2, K3 multiplier from this table itself, which is showing in the right hand side PDF, figure 26.81 to be referred. This table is only applicable for exposure category C, which is stated here. or for other exposure category B and C, we need to refer here B and D. So this table is common for all the three category. Next one is we need to calculate velocity pressure exposure coefficient. This is as per figure 27.31 of ASCE 0710. For that, page number 308 to be referred. So here in the right hand side PDF you can see the table which is showing the velocity pressure exposure coefficient KH or KZ. So based upon the exposure category and the height of the structure which we had selected here, I am getting KZ value, that is velocity pressure coefficient, as 0.9. So this value also calculated in this right side table of code sheet. So how it is calculated you can see here is, so based upon this table the factor are extracted from the table 26.3.1. According to the exposure category, the H-look formula is applied to extract the value of the respective exposure category C, and we had to define the height as 20 feet, and based upon the floor and ceiling and that extracted from the table for exposure category C for lower limit and upper limit, then using the interpolation method, the value of KZ is arrived here as 0.9. So the same value is taken to here. Next one is velocity pressure. So for velocity pressure we need to see the class 27.3.2 of ASCE 0710. For that we need to go page number 307. So here in the right hand side you can see the formula to calculate velocity pressure in SI system is 0.613 kz kzt kd. So we already having the value of kz kzt kd and v also. So applying this formula where v equal to basic wind speed in meter per second as we are considering for a SI unit, and kd is 0.85, kzt is 2.93, kz is 0.9. Applying this formula, we are getting 4.01 kilonewton per square meter as our velocity pressure. Next one is we need to find out the Gust effect factor. For that, class 26.9.1 of ASCE 7 to be referred. So page number 301 to be referred. So here you can see Gust effect factor in class 26.9.1. The Gust factor for a rigid building or other structure is permitted to taken as 0.87. So we can consider directly that 0.85 here. Next one is we need to assume solid ratio, or we need to calculate based upon our structure configuration. The solid ratio is nothing but the area of solid area divided to cross area. Cross area is a panel size. We need to calculate roughly by length into depth, and solid area is nothing but what are the member which are exposed to wind, that alone we need to calculate. That is a net area exposed to wind. So net area exposed to wind divided by cross area will give you the solid ratio. So as we are not having any structure model in this calculation, we are just assuming this solid ratio is 0.25. So based upon the solidity ratio 0.25, we need to calculate the pressure coefficient. This is as per figure 26.53 of ASCE 0710. For that page number 361 to be referred. So here you can see in the right hand side ASCE 07 2010 document. So force coefficient CF is given for tower cross section of a square and a triangle. To calculate the CF, the formula is provided 4 epsilon square minus 5.9 epsilon plus 4 for square. So similar like a triangle also one formula is given. So this formula are calculated in the Excel sheet here in the table of code reference. So you can see here in the Excel sheet now. So as per figure 29.53, so these are calculated here using the solid ratio epsilon. So there are two values, we are getting 2.78 for square and 3.4 for triangle. So by selecting this tower profile, we can get the pressure coefficient Cn. So next and final answer we are going to get is design wind pressure. So this is as per class 29.5. For that page 355 to be referred. So here in the right hand side you can see the formula to find design wind force. Anyhow, this calculating this design wind force, we need the area of a exposure or area projected to wind, but we are not having any structure model in this calculation, so we are going to calculate only the design wind pressure by ignoring this AF alone. So by ignoring this AF means that is area of projected to area of members which are projected to normal wind is a area AF. By ignoring this, we are getting the formula QZ into G into CF. So by applying this formula, we are getting 9.48 kilonewton per square meter. So with this, we can conclude that we have calculated the design wind pressure as per AAC 7 2010. Thank you. Look description for more related videos. Subscribe to this channel for more updates. Thank you.